thank you for having the chance to present our product and our technique here in the Envision Tech Talks. I want to talk today about how to realize high-resolution telecentric imaging lenses, and looking for an appropriate name for the presentation. I got that idea to call it the Megapixel Battle, because Megapixel Battle is done by the higher data rates over the last years that camera manufacturer doesn't make any cameras or any new cameras with 5 megapixel or 6 megapixel, but you see always news with 45 megapixel sensor, for example, with 51 megapixel sensors, with here that's a Teledyne that's 37 megapixel sensors, and it doesn't depend if it's own same G pixel E2V or Sony. In the end, every camera or every sensor manufacturer drives the possibility that more megapixels are possible, or also for standard cameras. And of course, the camera manufacturers take that chance and produce and offer and launches new cameras with high amount of megapixel. But in the end, optics have their limitations, and optics has to fit to the cameras that you in the end can use the optics and the cameras for your application. And so the questions are, how can we realize high resolution telecentric imaging lenses? Because we are a manufacturer, especially for telecentric portfolio imaging lenses. So the first point is high number of pixels means higher resolution. That's good. But on the other hand, larger sensor size and smaller pixel size drives the complexity of the lens that fits to that camera. We have a high demand on the field size because of the larger sensor size that fits exactly to the second topic today from vision and control.
Mr. Platz, may
yes?
I shortly interrupt you? Someone asked that you put your microphone a bit further away from your mouth, please.
Okay, it's too loud. Okay, better?
Thank you. Yeah, much better.
Thank you.
Thank you.
So, then you have high demand in aperture because of a smaller pixel size. Larger aperture improves the possibility to smaller pixels to better resolution. Then you have a higher demand in color correction for monochrome sensor when you have a wideband illumination, but especially for color sensors with biopattern or other color sensors. You have often a high demand in transition for Sill Optics sensors. You have to have a high transmission at 400, but also in the near infrared at 850 or 940 nanometers. In the end, you have always the aperture size, the field size, and the waveband that drives the complexity of a system, of a lens. And of course, you have to deal with to have an appropriate lens for a portfolio, for different applications, and you have to keep the pricing as low as possible. I translate that into lens specification. You need an effective f number of 8.0 or less. You need a sensor-sided field size larger than 17.6 millimeters, because that 1.1 inch is already standard, and it's now we're talking about these lenses that covers the sensors that have a larger diagonal. Then you need a waveband correction for wide illumination and for the biopattern that fits to that. You need that NIR correction in the transmission. You need a variable stop in many tasks, because you need a large stop, a large aperture for the high end. On the other hand, many telecentric imaging lenses and applications need a certain depth of field. So with a variable stop, you have that possibility to improve to exactly your application. And you need standard interfaces. and a small sensor-sided G-fray angle. That means that you have a small angle on the camera and the sensor to have no troubles and no struggles with micro lens arrays on the sensor. In the end, attractive pricing and availability is always important to get the chance to come into a project. So now I have 5 different examples from lenses from our portfolio. After that, I will describe a little bit more about markets and a little bit more about the possibilities of Sill Optics also in customization. One example at first is a high resolution lens with a C mount and with a good color correction. You see on the right side the MTF plot in 2 different ways, in the typical MTF plot and the MTF versus field. And typical values are 75 cycles per millimeter, that's the blue, 19 the green, and red is 100 for different pixel sizes. You can also see that here, and typically our habitual value is to have about 25 to 30% contrast. So that's the contrast on that side for these pixel sizes to have a good illumination, a good imaging of that lens fitting to the sensor. For entocentric design, these values are a little bit different. For telecentric designs, this habitual values are quite good, and we have a good experience with that. The maximum sensor size is larger, is 1.2. The maximum that you can have in a C mount, you have a high NIR transmission, and you have a certain possibility with a small working distance adjust to use that lens also at 850 nanometers. We have always also other magnifications for nearly the same setup, just the field of view changes here. The next slide is a very similar lens, but with a totally different magnification. It's 0.8, so nearly a 1:1 lens. All the plots on the right side, these one, and in the back, these are for, I could put everything on every slide, but I chosen that topic, having C-mount lens with high performance pixel specification and with good color correction, that fits together. So the same from the slide before is true for that slide. And here I just want to show the 2 necessities for the color correction. The axial color shift means that with a different waveband, you have a different focus position. You see that's corrected inside the diffraction limit. That are these two lines, is the diffraction limit, to keep the performance as good that you don't have to refocus between green or blue, for example. As I already told, for the NIR, we have to refocus. But these lenses are for many, many applications for the portfolio designed to have that correction here also for the NIR. That would be something special for example, a medical or hyperspectral application. And here you see the lateral color error. Even here, that's the diffraction limit, and we are beyond the diffraction limit, that the lateral color error, that means the color cast, the blur that you see, the blue line and the red line not in one, but a certain blur out of them, that is corrected for these lenses. And both lenses can be taken for different of application with these large sensor sizes. And even here we have different magnifications and 2 additional magnifications coming soon. Another magnification again is a magnifying lens for these large sensors with that diameter, and also for that small pixel sizes for the 3.45 and the 2.74 micron. In fact, when you have that 2.74 micron and you have a 3 times magnification, you have already a resolution in your object space that's less than 1 micron. An additional task for designing high resolution magnifying lenses is that the working distance, you have to be careful to do not have a very small working distance. You know that from microscope lenses where you have only 5 millimeters or 10 millimeters or even less. For a typical telecentric lens for machine vision, you need at least 50 millimeters. And with a larger aperture, you need a larger lens size, or for a larger working distance, you need a larger lens size. So that lens is a compromise with an f number of 10, but even with a performance that is quite good for these small pixel sizes. We have that lens also for different magnification, 1.5 up to 3.0. Even that lens is corrected for Bayer pattern and white, so having a good color correction, but here we don't have that IR spec because the aperture has to be much larger for 850 nanometers to keep that specification. We have a new lens, or 3 new lenses with different magnifications starting in May 2024, where we have that first lens I saw in another larger dimension, a larger brother lens for APS sensor with a maximum diagonal of 32.6 millimeters. That is the typical next level for all the cameras that don't have a C mount, but having an F mount or an M42 or that new TFL mount from which Edmund promotes. We don't know so many cameras with an M35 mount, so we have 2 standards, the M42 with a back focal distance of 12 millimeters or the F mount. Again, it's the F number of 8.7. We have a small G-ray angle that you can use that with micro lens arrays. We have that NIR transmission and working distance adjust. We have a large field of view, and we have that possibility that we have that specification that the lateral color error and the performance of the MTF is very good even in the corners of the lens. The last example is a 2x magnification lens with an integrated Optotune lens for refocusing, because everybody knows that a magnifying lens has a very small depth of field, and you can adjust with that lens the working distance to get a good performance with a variable focus. Optotune makes a test report last year or the year before already, and the performance stays the same. MTF for ±1 diopter change in the liquid lens. That means you have a 2x magnification lens for these small pixel sizes with that 113 line pairs, and you have a ±4 millimeter focus adjust. That's also a very special lens for these sensors with 15-20 megapixels. What are applications for these high-resolution telecentric lenses? Wherever telecentric lenses are required, a higher resolution is interesting. You have always to manage cost, efficiency, and your needs but for any dimension measuring and any object positioning application, it can be interesting. You have to choose your camera. Typically, everybody chooses the camera at first. And you have to take care of sensor size, pixel size, the G-ray angle, and the camera thread. And then you can contact us with an appropriate lens, with an appropriate magnification for your field of view. Markets for high resolution telecentric lenses are machine vision, semiconductor testing, bioanalytics, also where you have to detect the position and the intensity of different reagents, in different partitions, and of course optical measurement. We offer additional technical support for the telecentric lenses. Technical support for a component manufacturer like us is of course only what is a compatible condenser lens. You know telecentric illuminations, condenser telecentric illumination lenses, lens holders, and of course some modifications. We offer gluing and ruggedization, working distance modifications, and for larger setups, for larger projects, also fixed stop and integrated filter or coaxial illumination if that is needed. Just get in touch and discuss what you're planning. Sill Optics in general is a partner for optical assemblies. We are a company near Nuremberg and concentrating on laser optic lenses and imaging optics. At imaging optics, we have that standard portfolio I'm already talking about. Then we make a lot of business with a custom lens design. That's our main business, really from modification up to total new optical design for a certain specification. And we have some special designs that are built to order so that you can ask us, get a loan lens, test that lens, and then order a certain amount of lenses. For example, there we have also lenses up to 80 millimeters sensor diagonal, that big one on the right image, for example. For custom imaging lenses, we do not only offer telecentric designs, but also entocentric designs. For example, here a DMD lens that can be telecentric or entocentric at one side, but on the DMD side, always telecentric, and large field entocentric lenses for large sensor diagonal, for example. For us, it's very important to have a good knowledge about your needs and the possibilities of your setup. And on the other hand, our experience in the development, these are the key factors for getting a suitable lens for your project. So please just get in touch, describe your project, and we can recommend a suitable lens for you or recommend and pre-design a custom lens for your lens series. Our vision is to be an innovation leader that develops pioneering application solutions that are drawing global attention in the high-end field of photonics. So when you're with us, just join us, contact us. Thank you for your attention, and I'm looking forward to your questions.